What's going on, guys? So this is a continuation of the random tutorial, except that instead of looking at the vanilla random module, we're going to be looking at the Numpy version. Alright, so let's get started. So the first method that we're going to look at is np.random.rand. So rand is basically just going to choose a random float number between 0 and 1 via uniform distribution. So the first thing we need to do is import numpy as np. And then to access the rand, it's np.random.rand, and you feed in a number. And this number is going to represent the size. So here, since we're feeding in 10, we're going to get back a one-dimensional array, or you could think of it as a list of 10 numbers that are between 0 and 1, and they are sampled via uniform distribution. So uniform distribution basically says that numbers are divided to be between 0 and 1. So you could think of it as having an enormous amount of rational numbers between 0 and 1. Alright, so let's just run the first code, which gives us an array with 10 different numbers, and these numbers are all between 0 and 1. Alright, so that was a one-dimensional array. Now we're going to be pulling out a two-dimensional array, and the two-dimensional array is going to be a 5x2. So np.random.rand 5x2. So instead of getting back a single-dimensional array, we get back a 5x2 array. So 5 rows and 2 columns. Now next up, since we're feeding in 3 numbers, 2, 3, 4, we're going to get back a 3-dimensional array, also known as a tensor. So we run this, and now we get back 3-dimensional array. So this is going to be 1, 2, 3, 4, and then 1, 2, 3 rows, and that comprises of one single row. So it's basically 2 rows, and then for each of the 2 rows, there's 3 different rows within the 2 rows, and within the 3 rows, there's 4 columns. So hopefully that's not too confusing, but it's alright if you guys don't understand this, as long as you understand the basic concept. Alright, so that was uniform distribution. Now we can also sample via normal distribution. So it's basically between 0 and 1, except the distribution of the numbers are following a standard normal distribution. So if we run this now, np.random.randint 5, we're going to get back an array with 5 elements, all sampled from a normal distribution with a mean 0 and standard deviation 1. As you can see, we're getting numbers that are negative. This is because it's following a standard normal distribution. So np.random.randint, now we're going to feed in 2 numbers, and this is basically going to give us back a matrix or an array that's 5x2. So the difference is rand n is normal distribution, and np.random.rand is from the uniform distribution 0 and 1. Alright, so next up is random.randint. So you feed in a low number and high number and a size. So basically you're going to be extracting integers this time. So earlier we were dealing with floats. Randint is just going to be extracting integers. So if we look at the first example, numbers between 0 and 3, and the size is 5, basically means that our array is going to return to us numbers between 0 and 3 and 5 of those elements. So 1, 1, 0, 1, 2. So the high is exclusive. Now we're going to do the same thing, but our return output is going to be a 2-dimensional array, so it's going to be 2x2. So numbers between 4 and 6, and instead of getting a single dimensional, we're going to get back a 2D array. Alright, so get back a 2D array, 5x4 and 5x5, and these are between 4 and 6. Alright, now we're going to do the same thing, 2 and 10, so 2 is the low, 10 is the high, and we're going to get back a 3-dimensional array. So this is a 3-dimensional array. Alright. Random.sample. Okay, random.sample also generates random float numbers, but it is following a continuous uniform distribution. The earlier uniform distribution is supposed to be continuous as well. Now this gets into heavy mathematical theory, such as measure theory, etc., of what a continuous uniform distribution and Borel sets, etc. are. But for NumPy, basically the only difference between random sample and a random.rand is the way they accept their inputs. So random.sample is also a continuous distribution between 0 and 1. However, the input is going to be a little different. So let me just run this first, a random.sample, and this will return a single random floating number. But if you feed in, say, 2x3, random.random sample, you're going to get a 2x3 array, a continuous uniform distribution. Alright, so the difference between np.random.rand and np.random.sample is just how the input is inserted. So let's just go here. So np.rand takes in a 3x5, while np.random.sample takes in a tuple with the size. So that's basically the difference. They're both uniform distributions, and they're both going to choose numbers between 0 and 1. It's just the input is a little different. Here, you don't require a tuple. You just feed in the numbers. Here, the size has to be within a tuple. So I'll run this, and sample 1, sample 2. So basically, they're both uniform distributions between 0 and 1. np.random normal. Alright, so earlier, we were sampling from a normal distribution, but that was the standard normal distribution. So basically, standard normal distribution has a mean of 0 and a standard deviation of 1. Here, you can actually change the mean and standard deviation. So the mean is specified by LOC, and the standard deviation is specified by a scale. So mean, center of the distribution, scale, standard deviation, and the output shape. If size is none, it defaults to a single value. Alright, so mu and sigma, so we're going to specify the mean as 0 and the standard deviation as 0.1. So random.rand normal. The mu, sigma, and 100 is the size of the array. So this is from the distribution of a 0 mean and 0.1 standard deviation. Alright, so there's another method for random uniform. Instead of being limited to between 0 and 1, you can actually specify the low and high. So this gives you more granularity as to how to create your uniform distribution. So np.random.uniform. So we're going to pick numbers between 10.5 and 20.5, and the size is going to be 2.3. Next up, np.random.choice. Alright, so this generates a random sample from a given array, and you have the option of replacement or not, and it is going to generate a sample from a 1D array. So np.random.choice is going to be sampling from a 1D array. So this is actually used a lot for indices. If you want to randomly select an index from a list, so a list indices, this is a good way to do it, np.random.choice. Alright, so you can feed in an array, or you can feed in a number. So if you feed in an array, that's going to be the array that you're going to sample from. But if you feed in a number, say 8, the random sample is going to actually generate a range going from 0 to 8. So it's going to generate a range of numbers going from 0 to 8. So np.range 8. Of course, the size is the output size that you want, and replace is just asking if you want the sample to be sampled with or without replacement. And additionally, you can enter the probability of each entry in A. So if you want to weight certain elements more, you can do so by giving the probability distribution P. Alright, so if you don't give the probability distribution, the sample assumes a uniform distribution over all the entries in A. Alright, so let's look at the examples. We have single random choice, np.random.choice, array, and size equals 1. So here we're going to be choosing from this array, and the first line of code is just going to be choosing one number from this array. Now if you look at the second line of code, multiple random choice, that's going to use np.random.choice, array, size equals 3, so we're going to be choosing 3 elements, and we're going to set replacement to false. And finally, we're going to do the same, but this time we'll set the replacement to true. So let's just run this. Alright, so get back one random element from array. Then for the second one, multiple random choice, we pick out 3 elements, but this has no replacement. And finally, we get with replacement, so that's why you see duplicate number of 10. So for all 3 of these examples, we're feeding in a pre-made array. But as I said, you could also feed in an int. If you feed in an int, your sample size becomes an array with numbers going from 0 to 19. So we're going to sample a number between 0 and 19 with size equals 1. Alright, so if I just print no array, we get back a 6. So it's a number between 0 and 19. Alright, next up, np.random bytes, and you specify the length. So basically, you're just going to be pulling out random bytes of a certain length, so 10 bytes. And if I run this, so you get 10 bytes of random data. Alright, so Random seed. So we went over this in the earlier video with the Python vanilla random, but basically you set a seed, and once you set a seed, each random function you invoke is going to be reproducible. So here we set the random seed to 0, and then we're going to call np.random.rand5, and then we're going to follow it up by np.random.rand4. And we run the random function twice. Now, if we do the same thing over, setting the random seed to 0 and run those two random functions, we're going to be getting the same output. So this is very useful when you need to have reproducibility in your experiments. So let me just run this. All right, so if we take a look at the output, generating random numbers first time, seeding. So we get 54, 0.715, 0.60, etc. Then we ran it the second time, 0.649443. All right. So this was the first two executions of np.random under the seed equals 0. So we reset the seed back to 0, and then we ran those two random seed code lines once again, and you'll see that the output is the same. So set the seed, no matter how many times you run random, the output can be duplicated by setting the seed back to that number you specified and rerunning everything. So this is very good for reproducibility. Alright, so np.random shuffle sequence. So this is very similar to the vanilla random version. Remember, it's in place. Once again, if you forgot what in place is, check out the other random video. Another thing you want to note is if you feed in a multi-dimensional array, only the first axis of the multi-dimensional array is going to be shuffled. So you'll see what I mean by that. Alright, so we're going to create a sequence in np.random, which is just going to create numbers from 0 to 9, and we're going to reshape that to an array of 3 by 3. So we're going to print what the sequence looks like before shuffling, and then we'll shuffle, and then we'll print the sequence after shuffling. So if I run this, alright, so before shuffling it's 0, 1, 2, 3, 4, 5, 6, 7, 8. But after shuffling it's 0, 1, 2, 3, 4, 5, 6, 7, 8. Alright, so actually shuffling didn't do anything, so let me run that again. Here we go. So I was a little confused as to why the first two times. I guess that's just a rare an occurrence that shuffling just shuffled it back to the original array. But here I shuffled one more time, third time, so we get 0, 1, 2, 3, 4, 5, 6, 7, 8. But now you'll see the first row and the second row have been switched. So you have to be aware, once again, the shuffling only happens in the first axis. So the first axis are the rows. So you can't actually shuffle like something like 0 and 3. You can only shuffle the rows. So 0, 1, 2 has been shuffled or permutated with 3, 4, 5. Alright, so that brings us to the next method, permutation. So this is used to permutate a sequence and return a permutated range. Okay, it's very similar to shuffle, except there's two differences. First, it's not in place, so you actually have to save the output to a new array, and you can feed in a number instead of a sequence. So here, we needed to feed in some sort of sequence, but here we can feed in an integer as well, and that automatically creates a sequence of numbers 0 to 10. So here, np.random permutation 10 will automatically create a sequence of numbers going from 0 to 10, and then permutate that. So it'll look very similar to shuffle. Alright, so once again, we're going to create a 3 by 3 array, 0, 1, 2, 3, 4, 5, 6, 7, 8, and we're going to use np.random permutation. So here it permutes once again along the first dimension, so the rows are permutated, but let me see. If I run array, you'll see that the original array is still intact and it hasn't been permutated. Alright, so that's just the basic difference, those two minor differences. So NumPy tends to have a lot of methods that are kind of very similar with just minor differences. So it can get kind of confusing because you run into lots of code that are using all these different methods, so you kind of have to understand all these different methods. Alright, so if you want to get a more exhaustive list of all the random methods and all of the distributions you can sample from, gamma distribution, beta distribution, etc. There's a lot of distributions where you can sample numbers from. You could check out the docs, NumPy reference routines.random.html. Alright, so hopefully this just gives you a good introduction to a lot of the random methods that you run into in vanilla Python and NumPy Python. So, alright, so I think that's it for this video. So if you guys have any comments as to what you'd like to see please leave comments in the comment section, and you can also connect with me on Facebook, where I'll try to update what I'm working on and studying, etc. Alright guys, that's it for this video. I'll see you guys next time.